It's a big surprise. Nobody thought the ocean was this deep. So all of a sudden we've got scientists saying, why is that?
Nobody expected this. Not the depth, not the silence, and definitely not what the recorders brought back. For decades, scientists believed the deepest parts of the ocean were simple. Cold, dark, lifeless trenches where nothing moved and nothing changed. A place so extreme that reality itself slowed to a crawl. But the deeper we went, the more that belief collapsed. At nearly 7 miles beneath the surface, in a place known as the Challenger Deep, instruments began recording things that shouldn't exist. Sounds with no clear source, sudden bursts of energy, physical damage to machines designed to survive nuclear submarines, and patterns etched into the seafloor that don't match any known form of life. What's unsettling isn't just that these events happen, it's that they keep happening, and almost no one talks about them. Official reports stay focused on rocks and microbes, while raw sensor data tells a very different story, one filled with movement, force, and unexplained activity in a place that should be completely still. The deepest part of the ocean isn't just dark, it's crushing, it's hostile, and somehow it's not empty. Tonight, we're peeling back the layers of silence surrounding the deepest place on Earth. The unexplained sounds, the impossible biology, the damaged machines, and the terrifying questions scientists avoid asking out loud. What exactly is happening at the bottom of the ocean, and why does the deeper we look, the quieter everyone becomes? Most people think the deepest part of the ocean is the abyssal zone. It's not. That's where the real mystery begins. Below about 20,000 feet, the ocean enters a realm so extreme it has its own name, the Hadal Zone, named after Hades, the underworld. This is the deepest environment on Earth, stretching down through narrow trenches carved by tectonic plates colliding over millions of years. And at the very bottom of it all sits the Challenger Deep, plunging to nearly 36,200 feet, or 11,034 meters below the surface. To understand why this place terrifies scientists, you have to understand pressure. At sea level, the human body lives under 1 atmosphere of pressure. Down here, that number explodes past 1,000 atmospheres. The weight of the water above is so intense, it presses with more force than a rifle barrel during a gunshot. It's like parking dozens of jumbo jets on every single square inch of a vehicle and expecting it to hold its shape. This pressure doesn't just crush steel, it changes chemistry, it warps materials, it turns even the strongest metals brittle. Any empty space collapses instantly. Any mistake is fatal. That's why fewer missions have reached the Hadal Zone than astronauts who've walked on the moon. And yet, despite all of this, the ocean floor down there isn't chaotic, it's eerily calm. A thick layer of fine, undisturbed mud blankets the bottom, settling so slowly that a single footprint could remain visible for years. In theory, nothing large should move here, nothing fast, nothing powerful enough to disturb the sediment in any meaningful way. But the data tells a different story, because every time a probe touches the bottom, the instruments record subtle vibrations, unexplained disturbances, and signs of movement in a place that should be completely still. And once scientists realized the Hadal Zone wasn't as quiet as they thought, they were forced to confront an uncomfortable possibility. The deepest place on Earth isn't just extreme, it's active. And what moves down there is the reason the next discovery changes everything. The first time humans reached this depth, they weren't expecting to discover anything alive. The assumption was simple. Pressure this intense should destroy complex organisms instantly. But in 1960, that assumption shattered. The bathyscaphe Trieste descended into the Challenger, carrying 2 men, Don Walsh and Jacques Picard. As they sank deeper than any human ever had before, the world above disappeared, replaced by total darkness, and a hull groaning under unimaginable force. Then, near the bottom, something moved. Through a small viewing window, they reported seeing a flat fish-like shape glide away from the lights. It looked ordinary at first glance, and that's exactly why it was terrifying. A creature like that shouldn't exist under more than 1,000 atmospheres of pressure. That single sighting rewrote biology overnight. It proved that multicellular life could survive where physics said it shouldn't. But what rarely gets mentioned is what happened after the mission. The official reports focused on geology. The living creature became a footnote. The discussion quietly shifted away from animals and towards something else entirely, because later missions began noticing patterns that had nothing to do with biology. biology. Subtle movements on the seafloor, instruments registering motion without a visible source, and acoustic sensors picking up signals that didn't behave like earthquakes, currents, or known marine life. The deeper researchers looked, the more uncomfortable the question became. If simple life could survive down here, what else might be capable of adapting to a world built to crush and erase everything we know? And that question became impossible to ignore when scientists started listening instead of looking, because the sounds coming from the Hadal Zone didn't behave like anything they'd ever recorded before. Long before cameras could survive the pressure of the deepest trenches, sound became the only way to study what was happening down there. Light disappears quickly in the ocean, but sound travels for thousands of miles. And once scientists began listening closely, the Hadal Zone stopped sounding empty. Hydrophones placed near the deepest trenches started recording ultra-low frequency signals rising out of the darkness. Some of them were familiar: ice cracking near the poles, distant earthquakes, even the long, haunting calls of whales traveling across entire ocean basins. Those sounds were cataloged, classified, and understood, but a small group of recordings didn't fit. These signals didn't repeat like seismic events, and they didn't match the biological rhythms of known animals. They came from extreme depth, moved across the sensors, and then vanished. Researchers gave them neutral labels and moved on. Internally, the conversations were very different. One series of recordings captured near the edge of the Hadal Zone was described by a technician as a scrape followed by a shudder. Not a rumble, not a crack, a rigid, deliberate sound, as if something massive had shifted its weight across the seafloor. The signal was too sharp to be sediment movement and too slow to be a collapse. What unsettled researchers most was consistency. These sounds appeared only in the deepest regions and only when equipment was operating nearby. When probes descended, the recordings changed. When dives ended, the signals faded back into silence. Officially, most of these events were attributed to ice quakes, thermal stress, or distant geological activity. Unofficially, they were labeled unresolved and quietly archived. No press releases, no follow-up missions designed to investigate them directly, because once scientists accepted that something solid was moving in a place thought to be motionless, it raised a far more troubling question. If the Hadal Zone isn't silent, what else has been happening down there that no one has been listening to? Sound was only the beginning. Once landers and probes started spending real time on the seafloor, the data stopped being abstract and started becoming physical. And that's when the problems began. Several deep-sea missions reported unexplained energy spikes during Hadal dives. Sensitive instruments would suddenly overload or shut down entirely, despite operating well within their designed limits. These weren't gradual failures caused by pressure or cold. They were abrupt, localized events, as if something external had interfered with the equipment for just a moment and then disappeared. At the same time, temperature sensors began recording anomalies that made no sense. In a zone where conditions are supposed to be almost perfectly stable, brief temperature drops appeared without warning. Not the slow changes caused by deep currents, but sharp, sudden shifts that occurred far too fast to be explained by normal ocean dynamics. Then came the disturbances on the seafloor itself. The Hadal floor is usually covered in a thick layer of fine mud, so undisturbed that even tiny movements leave visible marks for years. Yet repeated missions began detecting large-scale disruptions in this sediment, patterns where the mud had been pushed aside, linear impressions that didn't match landslides or equipment drag. What made this especially unsettling was the scale. These weren't the faint traces of small organisms. They were deep, continuous disturbances that suggested weight and movement, something pressing down hard enough to alter the seafloor in a place defined by stillness. Individually, each anomaly could be dismissed: a faulty sensor, a calibration error, a minor geological shift. But taken together, the pattern was impossible to ignore. Something down there was interacting with the environment in ways that shouldn't be possible. And to understand why that matters, scientists had to confront a far more uncomfortable problem: the absolute limits of life itself. To understand why these disturbances are so alarming, you have to understand where biology hits a wall. Life doesn't just struggle at extreme depths, it runs into mathematical limits. And scientists thought they knew exactly where those limits were. The deepest fish ever recorded is the snailfish, discovered in the Mariana Trench at around 26,700 feet. Beyond that depth, things start to fall apart at a molecular level. Fish rely on delicate protein structures to function, and under extreme pressure, those proteins begin to collapse, similar to what happens when an egg cooks and solidifies. Once that process starts, survival becomes impossible. So how does the snailfish survive at all? The answer is a chemical called trimethylamine N oxide, or TMAO. It acts like a biological pressure stabilizer, protecting proteins from being crushed. But there's a limit. Too much TMAO disrupts the salt balance inside the body, creating a fatal internal environment. This means there is a hard ceiling to how deep a bony fish can go, and the snailfish is right at that edge. This wasn't a theory. It was calculated, tested, and confirmed. According to everything scientists understand about chemistry and physics, no fish should exist below that point. No fast-moving animal, no large vertebrates, nothing capable of sustained movement under even greater pressure. And that's where the contradiction becomes impossible to ignore, because many of the disturbances recorded in the Hadal zone appear far below the snailfish's maximum depth. They suggest size, they suggest force, and in some cases, they suggest speed, all of which violate the known biological limits of life under pressure. If fish can't survive there, what exactly is causing movement in places where life isn't supposed to exist at all? If vertebrates can't survive beyond a certain depth, that leaves only one possibility: invertebrates. And in the Hadal zone, invertebrates don't follow normal rules. One of the strangest patterns observed in extreme depths is a phenomenon known as deep-sea gigantism. In environments where food is scarce, temperatures are near freezing, and predators are almost non-existent, some creatures grow far larger than their shallow water relatives. The deeper they live, the slower they grow, and the bigger they become. A well-documented example is Abyssal gigantea, a type of amphipod that looks like a small shrimp. Near the surface, amphipods are barely an inch long, but in the deepest trenches, they've been found reaching lengths of over 13 inches. That's not a gradual change. It's an extreme biological jump driven by isolation and survival under pressure. The reasons sound simple, but the implications are disturbing. Food arrives only as marine snow, a constant but tiny rain of organic debris falling from the surface. Growing larger allows these animals to slow their metabolism, store energy longer, and survive for decades, possibly centuries, on very little input. Cold temperatures reinforce this process, further reducing energy demand. There's also something else at work. Predators are almost absent at these depths. Without the constant pressure of being hunted, organisms can grow at their own pace, uninterrupted. Size becomes an advantage rather than a liability. But here's where scientists begin to get uneasy. Some deep-sea footage, though brief and heavily degraded, shows shapes that appear far larger than known Hadal invertebrates. The images are too unclear to confirm anything, but they hint at proportions that don't match the documented size range of amphipods, sea cucumbers, or scavengers. Individually, these glimpses mean nothing, but combined with the unexplained tracks and energy anomalies, they raise a troubling possibility. If vertebrates can grow far beyond what we expected, then the true scale of life in the deepest parts of the ocean may be something we're not prepared to acknowledge. For years, the anomalies could be brushed aside as noise. Uncertain data, imperfect instruments, unclear footage. That changed during a routine unmanned dive near the Puerto Rican Trench. This wasn't an experiment pushing limits. It was a standard data collection mission operating well within expected parameters. At roughly 27,000 feet, the submersible experienced a brief power interruption. It lasted only seconds, just long enough for several systems to reboot. When the sonar came back online, it showed something no one expected to see. A dense object moved beneath the vehicle. Not drifting, not sinking, moving with purpose. The return suggested a length of over 25 feet, passing directly under the submersible before vanishing into the darkness. The speed alone ruled out known scavengers or slow-moving invertebrates. The crew initially assumed a sonar glitch. Thermal layering was suggested, a known issue where temperature differences distort acoustic signals. But internal diagnostics showed stable conditions. No layering, no interference. The signal was clean. What made the incident even harder to dismiss was timing. The object appeared immediately after the power disruption, as if something had approached during the brief moment the vehicle went dark. Then, just as suddenly, it was gone. The official report categorized the event as an equipment malfunction and closed the case, but internal logs tell a different story. Notes reference an echo-dense mass, rapid transit speed, and a size inconsistent with known deep-sea organisms. No follow-up dive was scheduled to investigate further, because acknowledging that contact would mean accepting a reality that science isn't ready to explain. Something large, something fast, and something operating far below the known limits of life. It isn't just what the sonar picks up, it's what returned from the seafloor when humans, or their machines, try to explore it. Deep-sea landers are engineering marvels, designed to survive more than 16,000 pounds of pressure per square inch. Titanium frames, ceramic spheres, reinforced electronics, they're built to withstand conditions that would crush a submarine like a soda can. And yet, time and again, these vehicles come back damaged in ways that make no sense. One lander, part of an early 2000s expedition, returned with a massive, deep gouge across the top of its titanium cage. Not a dent, a groove, as if something curved, incredibly strong and precise, had scraped it like a blade across the metal. The sediment at the bottom where it landed was soft, mud that gives under the weight of a single human hand. Yet the mark suggested a force far beyond anything expected in that environment. Engineers initially blamed rocks during descent, but there weren't rocks, only hundreds of feet of soft mud perfectly level. And the damage was localized, as if a single object had deliberately made contact. No chain marks, no collision traces, just a deep linear scar. Other missions reported similar anomalies. Pieces of scientific equipment disappeared entirely. Biodegradable bait cages designed to break away and float to the surface vanished without a trace. No metal, no debris, only a smooth depression in the mud, perfectly circular, as if swallowed by some immense invisible force. The pattern is clear. The Hadal Zone is not just home to strange, oversized life forms. It's also a place where physical interactions occur that defy our understanding. Things that are strong enough to gouge titanium, large enough to leave industrial-scale tracks, and fast enough to disappear before we can fully record them. And every time a lander returns with these scars, the official explanation remains neutral. Equipment error, sediment shift, or geological anomaly. Unofficially, scientists know the truth is far more unsettling because the ocean floor down here is no longer just a passive environment. It's a stage, and something or someone is moving across it. The Hadal Zone isn't just home to impossible light or mysterious machinery damage. It's a place where physics itself seems to bend, and where light and heat appear where they shouldn't. Below 3300 E, it's completely dark. No sunlight reaches this far. Yet some organisms produce light, bioluminescence, to hunt, attract mates, or defend themselves. Anglerfish dangle glowing lures in the black, shrimp flash warnings, and jellyfish pulse with their ghostly radiance. It's the only source of light in an otherwise absolute void. But some recordings from the Challenger Deep suggest a different kind of light, one too intense and broad spectrum to be bioluminescence. Brief flashes appear in images from ultra-deep landers too, large and bright to be from a single fish or squid. Some scientists propose sonoluminescence, a phenomenon where bubbles emit light under extreme pressure changes. But in the crushing, stable cold of the Hadal, there shouldn't be any bubbles forming naturally. Then there's the heat. While the trenches are usually just above freezing, hydrothermal vents release water over 850 degrees Fahrenheit. Submersibles passing nearby report sudden localized temperature spikes, sometimes jumping 60 degrees Fahrenheit in seconds. In one recorded event, a lander sensor spiked to nearly 95 degrees Fahrenheit before returning to normal within 3 seconds. The official explanation? Sensor drift. The truth is far more alarming. A sudden micro-eruption, an unpredictable geological burst, or something else entirely, hidden under miles of ocean pressure. And it's not just temperature and light. The tracks, the missing equipment, the gouged titanium, they all converge to suggest a terrifying possibility. Something enormous, strong, and fast exists in a realm that should allow only slow, tiny light, something capable of manipulating its environment in ways science cannot explain. Taken together, the Hadal Zone stops being a passive abyss. It becomes a place of contradictions, freezing water that carries heat bursts, complete darkness interrupted by impossible light, and light that should collapse under pressure yet thrives, while something larger than life moves just beyond our sight. The deeper we explore, the harder it is to separate reality from the unknown, and what happens next may rewrite everything we think we know about the deepest corners of our planet. The Hadal Zone isn't just extreme for life, it's extreme for the planet itself. The ocean floor here isn't a flat, stable expanse. It's a place where tectonic plates collide, grind, and shift, producing forces most of us can't even imagine. Subduction zones, where one plate slides beneath another, create narrow trenches like the Mariana and Puerto Rico. The crushing pressure of miles of water above hides immense geothermal energy. Hydrothermal vents, black smokers, shoot mineral-rich water at over 850 degrees Fahrenheit into near-freezing depths, forming towering chimneys that resemble smokestacks from some alien factory. The energy contained in this environment is staggering, but near the Challenger Deep, scientists have discovered phenomena that go beyond even these extremes. Pools of molten sulfur, hundreds of feet below the surface, bubble like boiling liquid in the blackness. Submersibles report that just passing near these vents risks corrosion, damage, and sensor failure. The sudden release of heat, pressure, and chemical energy is unpredictable, violent, and invisible to the surface world. Seismic activity adds another layer of danger. Minor tremors at the trench bottoms go largely unnoticed globally, but they indicate massive stress accumulating in the Earth's crust. A release here could produce shockwaves far stronger than the largest earthquakes ever recorded, and satellites have detected gravitational anomalies in places like the Puerto Rican Trench, hinting at dense mineral formations deep beneath the seafloor, sections of the crust that could store enormous energy. Taken together, these forces reveal a horrifying truth. The calm, dark floor of the deepest ocean is not safe. It's a thin, fragile lid over a simmering gorge of geological power. One misstep, or one unexplained event, could trigger a massive release, rearranging the ocean floor and sending shockwaves across the planet. In other words, the Hadal Zone isn't just the extreme frontier of life. It's a warning. Beneath that crushing silence lies a violent, untamed engine of heat, pressure, and energy, quietly shaping the world above. And what this means for the strange tracks, the impossible sonar reads, and the missing equipment is unsettling, because whatever moves down there doesn't just survive the pressure, it survives the planet itself. The deepest ocean is full of paradoxes. Tiny life thrives where pressure should crush it. Extreme heat coexists with near freezing water. And something, whether a creature, a geological force, or both, is physically interacting with the environment in ways that defy understanding. Submersibles return with deep gouges and titanium holes, missing equipment, and tracks in the mud that are too wide, too straight, and too deep to have been made by any known life form. Sonar picks up rhythmic clicks and scrapes with mechanical precision, yet no machine or human could reach them. Flashes of light appear where none should exist, sometimes accompanied by sudden, intense bursts of heat. Scientists call these anomalies unclassified or unresolved. Official reports focus on geology, biology, or equipment limitations, carefully avoiding conclusions that suggest something beyond current models. Internally, however, researchers know the data points to something extraordinary, a force capable of moving through the crushing depths, altering its surroundings, and leaving a trace of its presence without ever being fully observed. The Hadal Zone is not empty. It's a hidden world of colossal unknowns, a place where the rules of biology and physics are stretched to their limits. And the deeper we explore, the more evidence we uncover that the ocean floor is alive with activity we cannot yet explain. What is moving down there? A gargantuan predator? A species unlike anything on the surface? Or a force of geology that behaves almost like a living entity? No one knows for sure. All we can say is this: the deepest parts of the ocean are not silent. They are waiting, watching, and recording everything. The Hadal Zone keeps its secrets, but every dive, every sensor, and every observation brings us closer to the truth. The ocean's greatest mysteries are not hidden in the past. They are waiting for us at the very bottom, in crushing darkness, under unimaginable pressure. And what lies there may forever challenge everything we thought we knew about life, the planet, and the limits of possibility. By now, it's clear that the Hadal Zone is more than just a habitat. It's a hidden arena of forces, both biological and mechanical, operating far beyond human understanding. The anomalies aren't occasional. They are consistent. Tracks hundreds of feet long appear suddenly in soft mud. Sonar picks up massive shapes that vanish before they can be fully recorded. Landers return with gouges and missing parts, suggesting something down there has immense strength and purpose. And then there's the energy. Sensors record bursts of heat and flashes of light that defy explanation. Nothing in the known deep sea environment should be able to produce these events. It's not random. The timing suggests intention or natural cycles that science cannot yet interpret. Some researchers whisper about a force so immense that it challenges our understanding of physics. Could there be a life form adapted to pressures far greater than the snailfish limit? Could it be an unknown invertebrate, a megafauna predator, or something entirely different? Or are these anomalies evidence of geological phenomena that behave almost like a living entity, moving and interacting with the environment with precision and force? The more we explore, the more we realize how little we truly know. Every mission to the deepest trenches uncovers new data points that contradict prior assumptions, forcing scientists to quietly reconsider the limits of life, energy, and movement in the ocean's crushing depths. And the unsettling truth is this: the Hadal Zone is not static. It is alive with activity, much of it invisible, yet undeniably powerful. Every descent reminds us that the deep ocean is a world operating on rules we have only begun to glimpse, and some of those rules may be far stranger than anything on the surface. As we rise from the crushing depth of the Hadal Zone, one thing becomes clear: the ocean's deepest trenches are more than extreme environments. They are frontiers of the unknown. Every anomaly we've uncovered tells a story of forces both biological and geological that challenge everything we thought we knew about life and the planet itself. From the impossible survival of deep-sea creatures, to flashes of light and bursts of heat that defy explanation, from gouges in titanium landers to tracks in soft mud that no known life could make, the Hadal Zone is a realm where the rules of the surface world do not not apply. Here, pressure, darkness, and cold meet light, movement, and energy in ways that make our models of biology and physics feel incomplete. The hidden life down there, the snailfish at its deepest limits, giant amphipods, and organisms of unknown scale, teaches us that evolution can adapt in ways that defy imagination. But the true terror, or perhaps wonder, lies in what remains unseen. Massive forces moving silently, leaving traces that are recorded but cannot be explained. Geology adds another layer of awe. Hydrothermal vents, molten sulfur pools, subduction zones, and gravitational anomalies reveal a simmering, volatile planet hidden beneath the water. The Hadal zone is not passive. It is a living, dynamic world where energy builds, moves, and sometimes erupts without warning. The ocean floor is a thin lid over a force that could reshape everything above it, and it continues to guard its secrets with relentless pressure and darkness. And yet, the story is unfinished. Less than 5% of the seafloor has been explored, and each dive raises more questions than it answers. What colossal life forms may exist just beyond the reach of our sensors? What forces are shaping the mud, the rocks, and even the water itself? How much do we truly understand about the physics of life at this extreme? The Hadal zone reminds us that the planet's most extreme places are still largely a mystery, and that the universe beneath our oceans is alive in ways we cannot yet fully grasp. It is a world of contradictions, life thriving where it shouldn't, energy erupting where it seems impossible, and forces moving in silence that dwarf our imagination. The ocean's deepest mysteries are not in the distant past. They are waiting right now under 36,000 feet of water, in total darkness, under unimaginable pressure. And perhaps the greatest truth of all is this: the Hadal zone is alive, it is moving, and it is watching. If you want to uncover more of the planet's biggest mysteries and explore the extremes that science is only beginning to touch, don't forget to like and subscribe. Every dive into the unknown brings us closer to understanding the secrets that have been hidden beneath the waves for millions of years.